Okay, I hope today's chemistry regents wasn't too bad for everybody who took it. We're going to talk about this is the last regents in the green book. Hopefully, I'll do two 20-minute videos back to back, and I just picked a whole bunch of questions, and I hope it helps you, right? So, the first one, I'm going to put my calculator up here also, and I'll just zoom in and out. And I just want to talk about the calculator just for 1 second. So when you get there, right, you're going to have, they're going to do second, memory, and they're going to do 7, 1, 2, and everything's going to be switched. So you go back to your mode and go down to radians, right? We want to change radians to, let's see, I got to get back up here. Radians to degrees, and you'll see we're definitely going to use that in this regents. Okay, and we want to make sure that we're in A plus BI, because there is a couple of imaginary, there's one imaginary one on here. It's I squared, but if you forget I squared is -1, you can put it in your calculator and figure it out. All right, so the first question, here we go. So this one is one where it says find the exact value of sine 8 pi over 3. Well, 8 pi over 3 is in radians, so we're going to change it to degrees. So to do that, we're going to do 8 pi over 3, and our conversion factor is 180 over pi, and that's given to you in your reference table. So if you get there and you're like, oh my God, right? So it's 180 over pi to go to degrees. And then if you have a degrees, you want to go to radians, which isn't very likely. You just flip it. So if you do this, the pi's cancel out. And then you do 8 times 180 and then divide by 3. And we get 480 degrees. Okay? So then you can just go to your calculator, right? And you could put in sine of now I'm going to do it two ways, but I'm going to show you. We're going to just put in sine 480, right? Hit enter, and it's 0.8666. It's positive, right? So this is the square root of 3 over 2, which is choice 4. Now the reason why it's 4, right? Because the reference angle 360 goes all the way around, and then it ends up in the first quadrant, right? If you do 480, right? That's what that is, 480 minus 360. You get 120 degrees. You actually end up in the second quadrant. So I definitely just did that wrong. It's funny because I have it drawn right there and I didn't look at it. All right, so it actually ends up, it's 120 degrees. It goes around once and then it ends up here. And sine is positive in the second quadrant. Okay. This one is a teacher randomly divides her students into two groups. She grades homework in one group and doesn't do it in the other, and then she sees who does better on the test, right? So she's actually doing an experiment, right? She's experimenting with her little junior minds, and that's what she did. Okay, and then I hope she realizes that the ones that she doesn't grade the homework did worse, and she starts grading all the homeworks. All right, now there's a long way and a short way to do this. You can do x minus 2 times x minus 2 plus 27 x minus 2 minus 90. Okay, I'm going to do the shortcut. When you multiply these two, this becomes x squared minus 4x plus 4. Distribute this one plus 27x minus, maybe I'll move this over so you can see a little better, minus 54, right? 27 times negative 2 is negative 54 minus 90. And then you put all these together and you end up with x squared plus 23x minus 140. Okay, and then if you factor this, you end up with one's a plus and one's a minus. The ones that multiply to be negative 140 and add up to be 23 is 28 and 5. Okay, so this is choice 2. Now, how would I do that if I didn't want to? Well, me personally, I would let x equal 2, right? And then I chose 2 because I know that this one, and this one are going to become zeros, right? So I'm going to end up with 2 minus 2 raised to the second plus 27 times 2 minus 2 minus 90, right? And you're panicking on the test and you want to get more points. Maybe you skip this one. And this becomes a 0 and this becomes a 0. So this is 0 plus 0 minus 90, okay? Because of the word equivalent, and I'm going to stress that in a later problem also. Negative 90, right? Now, if you try them, if you go through and you put in 2, you're going to find out that 2, this becomes 32 times 1, right? Negative 1. If I put in 2, we're going to do the same thing, right? We're going to put in 2. If I do it in this one, you end up with 2 plus 28 times 2 minus 5. Right, this becomes 28, this becomes 30 times negative 3. Holy moly. Shut the front door. This one's equivalent to that one, so that also has to be done. Didn't have to do all the algebra. So when you see this word equivalent, and you have x's in both the answers and the questions, plug in a reasonable number. And just go ahead and do it. Okay, I'm gonna set my timer for 15 minutes. Okay, because I want to keep these kind of short. I don't want you to have to go through a whole one. Okay. Now here's another one. Same exact thing, right? Can you plug these numbers in? Put in 0.75, and I'm going to do that into these and see if they're what? Equal to each other. Right? So you can take each one of these for x. This one, we don't care about the y's, right? Put them in for x and see if you get the same thing for f of x and g of x. You know, it's not that serious, right? But if you wanted to do it by algebra, you would do 2x plus 5 over 2, which is equal to 3 over x. So to do fractional equations, you have to multiply every term by the least common denominator. In this case, it's 2x. Okay, so I'm going to do 2x times 2x. Right? I'm going to do plus 2x times 5 over 2 is equal to 3 over x times 2x. Okay, this one becomes 4x squared. This one, the 2's cancel out, and I'm left with 5x. This one, the x's cancel out, and this equals 6. So then, to solve a quadratic, you have to make it equal to 0. Plus 5x minus 6 is equal to 0. You do a quick rainbow, right? Multiply to be negative 30, and add up to be 5, right? So this is going to be x plus, and then x minus. Okay, and those two factors are okay, 4 times 6 is 24, not 60, right? So 24. So I need two numbers multiplied to be negative 24 and add up to be 5. So those two numbers are 8 and 3. And then we got to pay back the rainbow. We're going to divide by 4, and we're going to divide by 4. Right, so x plus 2 x minus 3/4, right? So my two roots here are x equals to negative 2, and x is the opposite sign, right, is positive 3/4. So we have negative 2 and 3/4. So number 1 is no good, right? Number 2, it definitely could be number 2, okay? And that's about it. This one is negative 2 and x is equal to negative 2, or that. They're giving you coordinates here, right? And the coordinates don't make sense because you don't have the right x's, right? This x is no good. This x is all right, right? They're trying to trick you. So this one is 2. Now, if you wanted to, you can plug the numbers in and make sure that they both do it, right? They both are equal to each other. You have 2 times 0.75 plus 5/2, right? Is that equal to 0.75 over x? I'm sorry, 3 over 0.75. Is that equal to 3 over 0.75? And you know, you can plug them in your calculator, right? I'll plug these in. Right, because I did it earlier, right? If you're worried about the fractions, right, put it in just the way you see it. 2 times 0.75 plus, give me the fraction here, right? 5 over 2. Hit enter. You get 4 on this side. And what's 3 divided by 0.75? Right, is equal to 4. So that works. And if you plug in the negative 2, you'll get negative 1.5 is equal to negative 1.5. Okay? So again, you didn't have to do it by math. You could have done it by algebra. You could have just plugged the numbers in and see if you have equivalence, right? Because we have this equal sign, this equivalent thing. All right, then we come to our first division of a polynomial by a binomial. All right, so we have x minus 3. This one you can't do any other way. I mean, I guess you could put it in. You could put a number in, but we'll see. You could try the remainder theorem and see if you get a remainder. And if you don't, right, then it would be either 1 or 2. But let's just divide this. 2x cubed minus 3x squared minus 5x. Now you notice we have them all there. We have a 3, a 2, and a 1. So we don't have to put in any zeros. All right, then we're going to do 2x to the third divided by x. This is equal to 2x squared. So we're going to put a 2x squared. And then we're going to multiply this times this is negative 6x squared. This times x is 2x cubed. And then we have to subtract. So we're going to change the signs. And we get 3x squared. Now, how many times? 3x squared divided by x is 3x. So we have plus 3x. Let's bring down the negative 5x. And we do the distributive property again, right? So we have 3x times negative 3 is negative 9x. 3x times x is 3x squared. We're subtracting, so we're going to change the signs. And here we're left with 4x. Bring down the 12, the negative 12. Again, 4x divided by x is equal to 4. So we're going to put plus 4 here. And we get negative 12 and 4x. When we change the signs, guess what? We have no remainder. All right, so this was choice 1. All right. Abby says there's a 50% chance it will rain. Which simulation can she perform the likelihood of it raining? Since we have 2 outcomes, 50% it'll rain, 50% it won't rain, right? The best thing to do is to flip a coin 7 times and repeat it 50 times, and count how many heads or tails. So this is flip a coin. All right. Flip a coin 50 times. Flip a coin 7 times. And repeat 50 times. Determine the likelihood it's raining for the next 7 days. Yeah, so we definitely want to do it 7 times. All right. Here we go. Number 7. Now, because these questions end up with radicals and i's, I'm going to use the quadratic formula. So this is a quadratic formula. All right, so we have to do 4x squared minus 7x minus 2 is equal to negative 10. I'm going to add 10 to both sides because we have to get it equal to 0. 4x squared minus 7x plus 8. So a is equal to 4, b is equal to negative 7, and c is equal to 8. The quadratic formula is given to you in your reference table. Negative b plus or minus b squared minus 4ac all over 2a. Okay, so let's put it in. And we have a negative 7, so we're going to do negative a negative 7. Right, when you work with the quadratic formula, it's best to put negatives inside of parentheses so you don't mess the signs up. This is negative 7 squared minus 4 times 4 times 8. Right, you can put in your calculator just like that underneath if you want. And then this is 2 times 4. I like to put negative 7 squared as positive 49. And this becomes minus 28. And then I'm going to clean it all up. A negative 7, a negative 7 is positive 7. 49 minus 28 is square root of negative 79 over 8. Now, 79 does not have a perfect square that goes into it. So basically, you really have 79, the square root of 79 times the square root of negative 1. And the square root of negative 1 is I. And because it's last on all of these choices, I'm just going to keep it last. 7 plus or minus the square root of 79 times I all over 8. And of course, they don't give it to you in that form. They actually use the distributive property, right? They do this divided by this. So you get 7/8 plus or minus this times this, because you could use the distributive property, which is the square root of 79 divided by 8, because you can only divide real numbers, times I. And this was choice number 2. All right. Now here's one, like we've gone along and we said, oh, you could just divide them. But now, we could just divide the binomial by the polynomial by the binomial and see if there's a remainder. And if there's no remainder, you have that could be a factor, right? So we're going to take this, x is equal to 5, and you plug it in, right? And if that's true, then this is a factor. So you're going to do p of 5, right? X is equal to 5. If that's equal to 0, then it is a factor. Okay, so this was choice 3. All right. And then we have our first. Now this Regents was good because they gave us both kinds of things that I want you to really know, so you don't blow 2 points. Right? In a small town, there's 22 gas stations. They give you a mean price per gallon. Right? Was 12. So X bar is 2.12. That's the mean, with a standard deviation of 0.05. They tell us it's normally distributive, approximately normal. Give this information the middle 95%. Well, 95% is the same as 2 varies by 2 standard deviations. So we're going to take the mean, 2.12, and we're going to plus and minus 2 standard deviations. Okay? And that'll give us the range of what the prices are in this town. So this is plus 2 times 0.05. And if you do this, you get 2.02. 212 minus 2 times 0.05. And this is, okay, I got them backwards. The plus, this is 2.222, and this one is 2.02. So we have a range of 2.02 to 2.22. So, you know, if we're driving through that town, we figure that out of those 22 stations, the prices have to be somewhere between those 2 points, which is number 3. All right. My buzzer's about to go off. Let's do this one. This one was hard. We'll stop with this one, then I'll make another video. Okay? Now, basically we could have done the easiest way to do this. Again, we have this word equivalent, right? We have this word equivalent. So we could put a number in for X and solve it. There is one number you shouldn't use for X here. You shouldn't use X equal to 1. Do not use. Only because we're dealing, do not use X equal to 1. Because, guess what? You're going to get 0 in the denominator, right? And we can't divide by 0. So you could pick any other number, right? You could use X. I actually did X is equal to 2. So if you put in 4 times 2 squared minus 5 over 2 squared minus 1, you plug that into your calculator, and you get this becomes 4 times 4 minus 5 is 11 over 2 minus 1, which is 1. So this became 11. Okay. All right, and then let's plug it into the first one. Oh, I'm sorry. This is 2 squared. This should have been 4, right? So this is 11 over 3. Okay, now let's try it with 1. Let's see if it works with 1. let's do 4 minus, and I know it works, so I'm going to just put it in. Right, 4 minus 2 squared minus 1, which becomes 4 minus 1 over 3. Okay, so if you go to your calculator, you do 4 over 1 minus 3, split screen, 4 minus 1/3. And then we could change this to a fraction. I don't know why this calculator does it. Bothers me. This is also 11 over 3. Okay, that's the easiest way to do something like that. The other way to do it is we can do 4 times x squared minus 1, right? Of course, we want the x squared minus 1, the x squared minus 1 to cancel out. Okay, right? Minus 5. Now, since we have this minus 4 here we have to deal with. So we're going to even it out by doing plus 4 over x squared minus 1. Okay, so this becomes 4x squared minus 1 over x squared minus 1. Okay, and then again, you could do this distributive property. If you do that, you end up with 4, right? Minus 1 over x squared minus 1. That's the way algebraically you would do it, but I think we'd all agree that just because we have that word equivalent, we could do it that way. All right, I'm going to see if I can post this one, and I'll be back with a second one.